Hello everyone, so in this video I will review the chapter coordinate geometry and we will be discussing the formula for midpoint, distance and gradient. We will also discuss the relationship between gradient of two parallel lines and two perpendicular lines. So let's get started. So for each of this topic I will directly mention the formula that we need to use to calculate them, and then I will solve one example problem. But then again, if you do not understand the derivation and if you do not know where the formula comes from, then what's the point of learning, right? So that's why I would like to discuss the derivation thing a little bit, and if you're interested in that case, you can check that out at the end of my video. Okay, so let's start. So as you can see, we have 2 points. Point A has coordinates x1 and y1, whereas point B has coordinate x2 and y2. And suppose the midpoint of this line AB is actually M, and you need to calculate the coordinate of the midpoint. In that case, the formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So basically you are taking the average of the 2 points, average of the x coordinate, average of the y coordinate. So to solve an example math, let me use a coordinate of A as 1, 2 and B as 5, 6. So in that case, the midpoint should be 1 plus 5, as in I'm taking the x coordinates, and then you are taking the y coordinates, 2 plus 6 divided by 2. So it's basically 3, 4. So that's the coordinate of this midpoint M. Next, we will learn how to calculate the distance between these 2 points. Suppose if you need to know the length of this line AB, in that case the formula is root over x2 minus x1 whole squared, y2 minus y1 whole squared, as in you are taking the difference between the x coordinate, difference between the y coordinates, and then you are squaring them and then adding them. Okay, so if I need to calculate the distance, so AB, if you need to find the length of AB, 1, 2, 5, 6, these are the 2 coordinates. So I will be using the x coordinate first, and then again it doesn't matter which one you are selecting as 1 and 2, it's up to you. So you just need to find the difference, right? So 5 minus 1, and then 6 minus 2. So this will give us a value of 4 root 2. The next one is gradient, which is actually the slope of a line that gives you an idea about how inclined your line is, the angle it makes with the horizontal line. So the steeper the line, the greater is the gradient, and the gradient is represented by M, and the formula for calculating gradient is y2 minus y1 divided by x2 minus x1. So for my example problem, the gradient should be y2 minus y1, so it's basically 6 minus 2 and then 5 minus 1, so that's 4 by 4 equals 1. So if a line goes up, in that case the gradient is actually positive. If a line goes down, the gradient is negative. If we are dealing with a horizontal line, in that case it doesn't make any angle with the horizontal, right? In that case the angle is 0, there is no inclination, so the gradient is 0 here. So M is 0. And if a line is parallel to the y-axis, in that case the gradient is actually infinite. Next, I will discuss the relationship between the gradient of two lines which are parallel to each other and perpendicular to each other. So suppose you have 2 lines. These 2 lines are actually parallel to each other, and it means they won't intersect. The gap between them is constant. So in this case, if the gradient of the first line is m1 and the gradient of the second line is m2, here m1 will be equal to m2, as in the gradients are equal. So for parallel lines, we have the same gradient. Okay, so for parallel line, we have the same gradient. But what if the lines are perpendicular? Suppose this is a horizontal line and that's a vertical line. We have a 90 degree over here. For example, the gradient of the first line is m1 and the gradient of the second line is m2. In that case, the product of the gradient will be -1. Okay, so the product of the gradient will be -1. So basically, if you have a gradient of this line as 3, and if you need to know the gradient of the perpendicular line, you can just use this formula and calculate the gradient of the perpendicular line. But then again, you can always use the shortcut method. As you can see, it's the sign is changed, right? The sign has changed, and the value here 3 is now 1/3, as in the reciprocal. Reciprocal of 2 is what? Half. Reciprocal of 5 is what? 1/5. Similarly, if you have a gradient of 5, we are supposed to find the gradient, and if we need to find the gradient of the perpendicular line, it will be -1/5, as in you take the reciprocal and then you just use a negative sign over here. If the gradient is 6, in that case the gradient of the perpendicular line will be -1/6, as in instead of using this formula, you can directly use the shortcut method, as in you just select the reciprocal. You can select the reciprocal, and obviously you need to change the sign. Okay, so if the gradient is 10, in that case the gradient of the perpendicular line will be 1/10, -1/10. So for parallel lines, the gradients are same, and for perpendicular lines, it's the negative reciprocal of the original line. So the concept of midpoint is very easy. You just need to find the average, right? So x1 plus x2 divided by 2, y1 plus y2 divided by 2, as in you are taking the average, the mean values of these two coordinates. Then comes the distance. For distance, you can just imagine a right angle triangle here, and this horizontal distance is actually the difference between your x coordinate, right? This is x1, that's x2, so this gap is x2 minus x1. Similarly, this height is at y2 and this is at y1. So this portion is y2 minus y1. So if you just consider this right angle triangle, and distance here is the hypotenuse, so you just need to use root over opposite square plus adjacent square. So that's it. That's the formula for the distance. So gradient is basically calculated using tan theta, where theta is the angle this line makes with the horizontal, the x-axis. So in our case, this is the triangle, so tan theta is what? Opposite by adjacent, right? So the opposite side is here, y2 minus y1, and the adjacent is x2 minus x1. So y2 minus y1, x2 minus x1, that's it. So that's it. We just covered the topic midpoint, distance and gradient. See you in the next video.